just for context here, Disbar's lab is explaining to the dipshit that is draft science that when you stretch a rubber band, it obeys Hooke's law much like a spring. He doesn't believe that, so we'll let him rant and rave, and then we shall move to a demonstration.
The rubber band only cares about how far you pull it back, not about the triangle shape.
Okay, so isn't that just amazing? He just said it doesn't matter. This hypotenuse doesn't matter. This is the only thing that matters, how far you pull it back. When, I've absolutely proven this hypotenuse matters. If this hypotenuse is 4 times more stretch, the rubber band stretched 4 times as much.
And to finish, a little bit of non-mathematical theory. Simple explanation: why the rubber band acts like a horizontal spring. The rubber band only cares about how far you pull it back, not about the triangle shape. When you pull the middle of the rubber band back, you feel a force trying to pull it forward again. That force is horizontal.
All right, so again, it's just ridiculous. And it's horizontal. If you put a force meter on this rubber band, the force it will read at 2 pulls is 4 times the force. At 2 centimeters, it's going to read 4 times the force. It will not read twice the force. And it's 4 times twice the distance, 4 times the force.
The sideways lengths are just geometry, not energy.
All right. The sideways lengths are where the rubber band is. That's the path the rubber band is traveling. For fuck's sake, how can it not affect the stretch of the rubber band when it's the path the rubber band is stretched on? Oh, I mean, it's just so dumb.
Set up there is simply a board with some centimetre line paper on, 2 screws that I can stretch elastic band between, and then it'll be clamped to the table, force meter in between, and just gently pull it back. Very, very simple. Right, so here we go. We're just going to gently pull it back. We get roughly to 1 centimetre of stretch, and we have 1.1 newtons. We go to 2 centimetres of stretch. We have roughly 2.3 newtons. We go to 3 centimetres of stretch, and we have roughly 3.5 newtons. We go to 4 centimetres of stretch, and we roughly have 4.65 newtons. We go to 5 centimetres of stretch, and we have 5.7 newtons. We go to 6 centimetres of stretch, and we have 6.8 newtons. And 7 centimetres of stretch, we roughly have 7.95 newtons. Right, so in conclusion, these are the results I actually got from a pretty rough, crude test. I would say, roughly, if we take it to 1.15 newtons and add that each time, we can see that that is pretty close. So that first reading was probably more like 1.15 newtons. The thing is that the meter goes up in increments of 0.5s, and a little millimetre here there is going to change it. But the main point to take from this is that we can see with distance the increase in force is linear to distance. By your theory, it's 7 times the distance of stretch. We'd be looking at 49, or to be fair to your argument, 45 times the force, and that's not what happens, is it? So sorry, but wrong again. So your love of saying hypotenuse and Pythagorean, nice new words you've learnt, but not applicable here. I'm afraid. And I'm quite shocked you accepted the Pythagorean theorem so openly, because, you know, it doesn't have one square term, but not 2 square terms, but 3 square terms in it. I'm surprised that didn't send you into a total fucking snowflake meltdown. But, you know, those tricky little square term critters, you know, not a problem when you think it somehow proves you right. But in this case, I'm afraid, again, with experiment, with real world demonstrations, you proved wrong again. Try harder.
Looks like I picked the wrong week to quit smoking.